welcome to 10.1 Graphs of Sine Functions. In this video, we're going to be taking a look at properties of the sine function. We're going to be taking a look at the graphing of that sine function and things to keep in mind when it comes to how to graph it, as well as how to be able to read an equation and be able to graph. So, on slide 2, here we have a classic sine function and the various properties that go along with it. First thing to keep in mind is that the domain will go from negative infinity to positive infinity, and it does include all real numbers. Now the range is restricted from -1 to +1, and it is inclusive, which means that it does include the -1 and it does include the +1 as well. When we are looking at the symmetry of a sine function, the first thing that we have to be able to understand is that it is an odd function, which means that when we look at the graph, it is going to reflect over the origin. So as you notice, it goes down through the origin and into the third quadrant. This would make it odd. Now, if it went ahead and reflected the y-axis, this would be considered an even function. So that is something that we have gone over in previous slides. Just keep in mind, in this case, it would be an odd function. Now, when we consider a period is the amount of distance that it takes for the graph to repeat. So if we were to start here at 0, 0, the origin, for us to see when it is, again, that the entire graph repeats itself, that would be at 2 pi. Now, initially, many people would say, well, what is going on over here at pi? Isn't it repeating it again because it's crossing the x-axis? Not necessarily. So in this case, at the origin, notice we are going from left to right and we are increasing. When we hit pi, we are actually decreasing, not increasing, which means it is not going through a full cycle. It is still in the process of getting back to a full cycle. Notice at 2 pi, it once again is increasing from left to right. So we could say that the period is a length of 2 pi. Let's take a look at the x-intercepts. Now the x-intercepts are whenever the line itself crosses the x-axis. So in this case, we have -pi, 0, pi, 2 pi, and we can consistently figure out from there that it would increase by 1 pi every time as we are going further right, and it would decrease by 1 pi as we went further left. Now, just because the only thing that we can see is between -pi and -2.5 pi, from -pi to a +2.5 pi, does not mean that it does not continue to occur. Notice the arrows at the ends. This means that that cycle will continue to happen every pi, whether increasing towards positive infinity or decreasing to negative infinity. So, as we take a look at our x-intercepts, this would be best described as ... -2, negative infinity, 0, pi, 2 pi, 3 pi, ... The reason for the ... once again, is because it continues to occur till positive infinity, and it continues to occur to negative infinity. In relation to our y-intercept, notice it only goes over the y-axis a single time, and that occurs at 0, 0. So our y-intercept is 0. Once again, if we're taking a look at maximum values, we have a maximum value of 1 in reference to the y and a minimum of -1. Now, the same way that we were taking a look at what was occurring at 2 pi, which is a cycle, what occurs is that every time that we have a cycle occur, it will hit the maximum point once and a minimum point once, which means if we were to increase and go a cycle of 2 pi, 2 pi would be equal to 4 pi over 2. So considering that, we would go ahead, we would take a look at our maximum value, which would be pi over 2. And we can go ahead and add 4 pi over 2 to that to figure out when would be the next maximum value. So it would go pi over 2, 5 pi over 2, 9 pi over 2, 13 pi over 2, 17 pi over 2, all the way up to infinity. And the same can be done on the negative side as well. This is very similar to kind of figuring out a coterminal, right? Where we would figure out exactly what that 360 would be, or figuring out what that 2 pi would be and adding the 2 pi to that initial point and finding other maximums or other minimums at that same time. Let's go ahead to slide 3. In slide 3, we go over some of the vocabulary that is used within this section. First thing is the amplitude. The amplitude is half of the vertical distance from the maximum height to the minimum height. So ultimately, we are looking from the midpoint to the maximum or the minimum, depending. Now, this can also be described as the absolute value of A. And you'll understand further once we kind of go over a couple more slides exactly what that means. Now, an interval. An interval is the domain of one cycle, written as x to the b, comma, xe, where xb is the beginning and xe is the end. So if we go back to slide 2, an example of that would be if we began at the 0, 0 or our origin. If we were writing the interval starting at our origin, we would be writing it as 0 to when it completes, which would be to 2. And we would have a closed bracket. So that would be from 0 all the way up to 2. Next thing would be a period. A period is a horizontal length of one repeating pattern of the function. Now this period can happen anywhere. We can see this occur from 0 to 2, but we can also see this occur from 0 to -2 pi. So it can occur in any direction as long as it is going through an entire cycle through that phase. Let's take a look at a phase shift or a horizontal shift. A phase shift or horizontal shift is the movement that it makes left or right within that function. Now, it is a movement left or right as far as the entire function being moved. It is not describing how far the horizontal shift moves. So keep in mind, it's not saying that we're going from 0 all the way up to positive and negative infinity. It would be saying if that point of the origin were to move to 1 pi, that would be the horizontal shift of 1 pi, is if that point were to move from 0, 0, and now instead of it crossing this method at 0, 0, it would move to this method over here at pi. The vertical distance of a function would be considered the vertical shift. Now that vertical shift would be similar to the horizontal shift. If the entire function were to move up or down, that would be considered the vertical shift. Very last thing to keep in mind for the interval is that the horizontal starting point and ending point of one complete period of a cyclical trig function is the interval. On slide 4, we start going over a sinusoid function. Now, this is extremely important because you have to keep in mind what the original equation is. This is the function where a times sine of bx plus c plus d. Now, a, b, and c, as well as d, are all constants, but we cannot have a or b equal 0. Now, these are extremely important because they help to tell you different aspects of our graph. Keep in mind, when we said and we began talking about our amplitude, we were referencing the absolute value of a. Remember, a is in reference to this a right here of our equation. In slide 5, we begin to talk about the midline. The midline is the middle of the maximum and minimum of that graph. So when we take a look at this blue equation, notice we have a maximum of 3, we have a minimum of 1. The midline would be that y is equal to 2. Notice if we were to add 3 and 1, divide by 2, we would get that midline. So the midline is the middle of a periodic graph. Keep in mind, when we are looking at a periodic graph, we are only looking at where it begins and the cycle ends. So in this example, we are only looking at one specific period, and that goes from 0 up to 2 pi. So it is the halfway point between the maximum and minimum values of an oscillating graph. Now, if we were looking at the red equation, it would be slightly different because notice we have here a maximum of 1 and a minimum of -1. So in that case, the midline would be 0. Let's go ahead and take a look at slide 6. Here we start talking about the amplitude. The amplitude is always going to be the absolute value of a. So that would be this a that we spoke of before and this a that we spoke of before. Now that would occur with both, not only a sine, but a cosine function. Not only a sine, but a cosine function. Let's try a sample problem. So here we have graph of y is equal to 3 sine x. Y is equal to 3 sine x. Now the one thing to keep in mind with this problem is that it will always start at the midline. Always start at the midline. And that is always something to keep in mind. It will always start at the midline. Now, as we work this problem, I will generally suggest go ahead and write your function out as far as your sinusoid function. So we have f of x is equal to a sine of bx plus c plus d. Now, in this case, we're going to start with the easiest part, which is going to be the amplitude. Now, the amplitude, remember, is the absolute value of a, which in this case is going to be 3. Notice the 3 is in the a position, and we're looking at the absolute value of it. Now, when we're looking at the period In order to figure that out, you're going to multiply 2 pi and divide it by b. Now in this case, our b, which would be in this position right here, would also be what is in front of the x. In this case, it is 1. So when we go ahead and work this problem, we're going to say 2 pi over 1 or 2 pi as a final answer. Let's go ahead and look at the subinterval. The subinterval we get by getting our period, which notice we just solved for 2 pi, and dividing by 4. So we're going to go ahead, get 2 pi, divide by 4. In this case, our 2 and 4 simplified to 1 and 2, which means we would end up with pi over 2. Let's take a look at our phase shift. We're going to go ahead and find our phase shift by taking a look at the equation of negative c over b. Now in this case, because we have no negative c, that would actually be 0. And it's going to be divided by b, which is our 1. 0 divided by 1 is 0. So there is no phase shift or horizontal shift. Now let's take a look at the vertical shift. Our vertical shift can also be known as our d of our equation, or the midline. In this case, you can easily see there is no midline, there is no d, which means our vertical shift is 0. Let's go ahead to slide 8. Slide 8, we begin by talking about the period. Once again, we figure out what the period is by getting 2 pi over b. And we're always looking at the absolute value of b. Now this will be the same for not only a sine function, but also a cosine function, if we were to look at an equation. So this is extremely, extremely important. Let's go ahead and take a look at another example. We're going to begin with our amplitude. Now, in this case, we're going to go ahead and start off with our equation of f of x is equal to a sine bx plus c plus d. Now in this case, we can easily see that we do not have a number in front of the sine, which means there is a 1 that is currently there. So our amplitude is 1. Let's go ahead and take a look at the vertical shift. Now our vertical shift here, notice to the right-hand side of our parentheses is our d. Now in this case, what ends up happening is, since there is not a number, our vertical shift is 0. We're going to go ahead and take a look at our horizontal shift. Remember, the horizontal shift is figured by getting negative c over b. In this case, it would be 0. It would be 0. Now, once we go over to our period, remember the period is determined by getting 2 pi over b. So in this case, we are looking at 2 pi, and our b, keep in mind, is 1/2. We have the 1 in front of the x over 2. So when we go ahead and solve that, that would actually give us 4 pi as our period. Our subinterval, which is our last step, is going to be our period, which is 4 pi, divided by 4. In this case, pi is our subinterval. Let's go ahead to slide 10. Now here on this slide, we have all of our important equations on one page. Now, whether we are doing y is equal to a times sine of bx plus c plus d, or cosine, notice our b will be greater than 0. Our b would be greater than 0. Once again, it goes over amplitude being the absolute value of a. The period is 2 pi over b. The phase shift is negative c over b. And the length of each subinterval is the period divided by 4. Using these equations, you're going to go ahead and work on slide 11. What I would suggest, pause the video now, work on slide 11, and find your answers. So on slide 11, first thing that we're going to do is write our equation. The more you write it, the more I can guarantee you, you will remember it much easier. So the f of x is equal to a sine of bx plus c over, or plus d, I'm sorry. First thing that we're going to begin with, we're going to go ahead and find our amplitude of y is equal to 2 sine x. Amplitude would be 2. Our period is going to be 2 pi. Now remember, the period is 2 pi over b. Amplitude is the absolute value of a. Our phase shift is negative c over b. And our subinterval is the period divided by 4. And our midline is generally the d of the equation. So on this slide, keep in mind we have 2 pi and for this equation, our b is actually 1, which means 2 pi is our answer. Next, negative c over b for our phase shift. In this case, we have 0 over 1, which is equal to 0. Once we have our pi being at 2 pi, this is going to be 2 pi over 4, which is equal to pi over 2 for the subinterval. Notice in this equation, we do not have a midline, or we do not have a letter d in the equation, which means our midline is going to be at the 0 mark. Let's go ahead on to our next equation. Here, absolute value of negative 1 is 1. We have 2 pi over 2. Notice that 2 is coming from the 2 in front of the x, which is leaving us with a period of 2. We look at negative c, which is going to be 0 over 2, which is still equal to 0. Our period, which is pi over 4. In this case, we cannot simplify, so it stays as pi over 4. And our midline is still 0. Next slide. Correction, next problem. We have amplitude of 3. We go ahead, look at 2 pi over b, which in this case is going to be 2. We're looking at pi for our period. Negative c. Now in this case, we actually do have a c. Our c is going to be a negative 1. So a negative of a negative 1 would leave you with positive 1 over b, which is 2. Keep in mind, anytime that you have a c, in this case, it is going to be negative pi, which means you write down that pi. Your answer here is going to be 1/2 pi or pi over 2. Let's take a look at the subinterval. This is going to be your period, which is pi divided by 4. And our midline, notice since there is no d, would still remain at 0. Next problem, our amplitude would be 1/2. Our period is 2 pi over b, which is 4. In this case, pi over 2. We're going to grab our negative c. So in this case, negative 3 pi over b, which in this case is 4. In this case, we can't simplify, so it stays just as it is. Our period is pi over 2 divided by 4. Now, in this case, we're going to end up with an answer of pi over 8 for the subinterval. Notice we still do not have a d on the outside of the parentheses, which means our midline is 0. Our amplitude here for the next problem is 2. Our period is 2 pi over 4 or pi over 2. We have negative 3 pi over 4 for our phase shift. In this case, our period was pi over 2. And we're going to go ahead and divide by 4, which is once again pi over 8. And in this case, we do have a d, which means our midline is going to be at 1. Last problem, amplitude would be 3. Period is 2 pi over b, which is 1/2. In this case, this will end up being 4 pi. We go ahead to the phase shift, which is negative c over b. Now this is going to turn that negative pi to a positive pi over b, which is 1/2. We're looking at 2 pi as a final answer for the phase shift. Our subinterval is our period, which is 4 pi over 4 or just pi. And our midline is 2. Let's go ahead and take a look at slide 12. As we take a look at this slide, the first thing that I would suggest is writing our sinusoid function, and that would be f of x is equal to a times sine of bx plus c plus d. This will help you keep all of your variables in order, and help you see what we are working with each one of our different questions that we are being asked. Now, let's start off with our amplitude. The amplitude is always going to be your A. So in this case, amplitude is the absolute value of A, or in this case, it would be 2. Our next would be our period. Now the period is generally calculated by getting 2 pi over B. So first thing we would take a look at is 2 pi over B. Now in this case, the B is in front of our x, which means this is going to be 2 pi over 1, which is equal to 2 pi. Once we've figured out what the period is, we can go ahead and solve for the subinterval. The subinterval is the period divided by 4. Our period right now is 2 pi, and we're going to place that over 4, which is equal to pi over 2. Our next step would be our phase shift. Our phase shift is negative C over B. Now in this case, we do not have a C in this example, which means we are going to end up placing a 0 in its place. So this would be 0 divided by 1, which is equal to 0. Our midline, or our vertical shift, can be found by going ahead and looking at the D of this equation. In this case, once again, we do not have a D, which means our midline would remain at 0. Lastly, the range would be calculated by taking a look at the midline and taking a look at the amplitude. Now, from the midline, we would be increasing or decreasing by 2 units, which means our range would go from -2 to a +2. Now, as we use this information to start graphing, we're going to go ahead and start with our midline. Midline is drawn using a dotted line across the x-axis. We then take a look at our phase shift. Our phase shift tells us where we would begin drawing our entire process. Now, in this case, we would be starting off at 0, which would be right here. And we would also want to go ahead and mark our amplitude. In this case, we would be going to a maximum of +2 and dropping down to a -2. Next, we would take a look at our subinterval. Our subinterval tells us the distance in between each of our different points. So we would begin with pi over 2 and increase until we have reached that 2 pi, or once we have gone through a full cycle of a period. So we have pi over 2. This is 2 pi over 2, 3 pi over 2, and 4 pi over 2. Our final step for this problem is going to be taking a look once again at the problem itself. Notice we have a negative sign at the very front, which makes it a reflection of our regular sine function. Generally, we would start by increasing as we go towards the right. In this case, we would actually decrease. So our first point would drop down to the minimum, come back to the midline, go to the maximum and drop back down once again to the midline to end the full cycle of our sine function. We would go ahead and connect all of these dots. Notice we want to draw arrows going on both sides due to the fact that this cycle would continue to happen period after period. Now let's go ahead and take a look at slide 13. Now we're going to work the problem the exact same way. In case you need to write it down, I would suggest going ahead, writing it down. F of x is equal to a sine of bx plus c plus d. Our amplitude in this case is going to be 2. Our period, remember, is 2 pi over b. 2 pi over. Now in this case, our b is going to be 1, which means our answer is 2 pi. Now, I want for you to understand something. This is a little bit different. Now, before we always had parentheses surrounding our bx plus c. In this case, our parentheses are occurring only around the x. This plus d, or plus 1, is the d portion of our equation. So that is something to keep in mind when looking at and graphing our equation. Our subinterval is going to be the period, which is 2 pi divided by 4, which is pi over 2. Our phase shift is going to be negative c over b. Now in this case, we do not have a negative c, which means this is going to be a 0 over 1 or 0. Our midline in this case is going to be the d, or positive 1. And our range is going to have a reflection based off of our midline. So in this case, if our midline is 1, we are going to increase by 2 and decrease by 2. So our maximum number would actually be a positive 3. Our minimum number would be a negative 1. So our range here would be from negative 1 to positive 3. We're going to first start off by graphing our equation. Now, in order to start graphing that equation, you're going to start off with drawing that midline. In this case, we are at positive 1. That midline will always be drawn as a dotted line. In this case, because we do not have a shift to the left, we are going to go ahead and we are going to start at 0. Now in this case, once again, we're going to go in increments of pi over 2. So this right here would be pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. With our subintervals being every pi over 2, we know that our maximum number is going to occur at 3. Our minimum number is going to occur at negative 1. We're going to go ahead at pi over 2, go off to the top. It will hit that midline once again at 2 pi over 2. It will drop to negative 1 at 3 pi over 2. And at 4 pi over 2, it will once again hit that midline. You're going to go ahead and connect all of the dots to be able to show our sine function. In slide 14, in this scenario, we actually have an equation with all four of our terms. Keep in mind, this will be our A, this is our B, this is C, and that is D. So let's go ahead. Let's take a look at our amplitude. Our amplitude in this case is going to be 2. Our period is going to be 2 pi over B, which is 2. So we're looking at pi. Our subinterval is the period divided by 4. So pi over 4. Our phase shift is going to be a negative C over B. So we're looking at a pi over 2. Now, considering how our subintervals are occurring at pi over 4, we're going to want to go ahead and convert this pi over 2 to be 2 pi over 4. This is going to make it a lot easier for you to be able to graph and keep everything in the same organized graph. We're going to go ahead and take a look at our midline. Remember, our midline is coming off of our D. So in this case, it's going to be -1. And our range, once again, if we're starting off at -1, we are going to increase and decrease by 2, which means we're going to go from -3 to 1 within our range. We're going to go ahead and first graph our midline. Remember, dotted lines describe our midline. We're going to go ahead and write in exactly what is going on here. So we have 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. This over here would be pi over 4. Now, knowing that our subinterval is pi over 4, it will make our lives a little bit easier to have an understanding of exactly how much we are moving. Now, in this case, our phase shift is occurring by 2 pi over 4. So we are going to shift right two pi over 4, and that's going to be our starting point. So 2 pi over 4, and we're going to start that at the midline. Our midline is -1, and we're looking for 2 pi over 4. We still have a subinterval of pi over 4, which means we are going to hit the maximum, which is it at 1 at 3 pi over 4. We are going to drop back down at 4 pi over 4, and it once again hit that midline. We are going to hit that minimum number of -3 at 5 pi over 4. And we're going to hit the midline once again at 6 pi over 4. We're going to go ahead, connect our dots, and be able to graph that. Last slide we're going to take a look at is slide 15. In this case, we're going to go ahead. We can label each one of the pieces that we have. In this case, A is -1, B is a +1, C is our positive pi, and D is -3. We'll start off with the amplitude, which is the absolute value of -1, which is 1. Our period is 2 pi over B, so 2 pi over 1, which is 2 pi. Our subinterval is the period divided by 4, so 2 pi divided by 4, or pi divided by 2. Our phase shift is -c, so -pi over 1. So that's going to leave us with -pi. Also keep in mind, what is our subinterval? It is pi over 2, so we're going to want a denominator of 2. In order for that to balance out, this would have to be a -2 pi over 2. Our midline in this case is going to be our D, which is -3. And we're going to increase and decrease by 1, which means we're looking at a range of -4 to -2. So the first thing we're going to do is label our minimum and maximums. In this case, -2 would occur here. -4 would occur there. Now, if we have a period of 2 pi, we're first going to have to understand what is our subinterval, which is pi over 2. So in this case, we're going to have pi over 2, 2 pi over 2. We're going to have a -pi over 2 and a -2 pi over 2. We're going to go ahead and start off at 0, 0. Well, not necessarily 0, 0, but we're going to start off at the 0 of our midline, which in this case is going to fall directly on our y-axis. We're going to increase to the maximum by pi over 2, and it will go back down to 2 pi over 2. Now, on the left-hand side of things, that shift of -pi over 2 means that we would go ahead and start off at -2 over 2 for the pi. It would decrease to -4 and increase back up again. So in this case, we're going to connect the dots. This right here is our 10.1 section. If you have any questions, please feel free to reach out at any point.